We are here with Group 13 comprised of boron, aluminum, gallium, indium, and thallium. The first element I'm going to interview is boron. Let's make some noise. Who are we here with today?
Boron.
Hi boron, tell the audience about yourself. We all know that you're used to make slime.
Yes, I'm used to make borax, which is an incredibly important ingredient in making slime. Not only am I used to make slime, but I'm also used in laundry and to increase hardness in steel, which is very important to our industry. Not only that, but my isotope boron-10 is used for nuclear applications, meaning that I can help the world progress towards cleaner energy instead of fossil fuels.
That's great. We love an element that has reliable use in our society. How can we recognize you? What are some of your general properties?
In my pure form, I'm a black lustrous semiconductor, meaning I'm a conductor at high temperatures and an insulator at low temperatures. That means I'm perfect for all seasons, winter or summer. I'm also hard, resistant to heat, and tough. So if you're ever a damsel in distress, I got you. I'm a 9.3 on the most hardness scale, which is comparable to diamond. We all know diamonds are expensive and you wish you had them, but you don't. You know what you could have instead, though? Me. I exist in crystalline anamorphous structures and an oxidation state of 3. I can form stable compounds with a large range of elements, making me super versatile and fit to be your politician.
Super interesting. I love diamonds, so if the audience loves diamonds, they should vote for you too. Now, tell us about your abundancy in isotopes.
I'm super rare, making about 0.001% of the Earth's crust, but you can find me in rocks and minerals. My isotopes, boron-10 and boron-11, are my two naturally occurring isotopes. Boron-11 is my most common stable isotope, and I can form several allotropes and stable compounds.
That's great. We love a stable and reliable element, but before we interview aluminum, is there anything else you would like to share?
Yes, I'm the metalloid with the highest boiling point and melting point, which makes me extremely special and therefore fit to be your president.
Okay, on to the next element. Who are you here with today?
Aluminum!
Hi, aluminum. You look pretty decked out. How are you today?
Not gonna lie, I'm feeling pretty icy.
That's amazing. Before we start with the questions, tell the audience about yourself.
Since my boiling point is 2,519 degrees Celsius, I'm a great thermal conductor, and I melt at 660.323 degrees Celsius. I'm a lightweight silver metal that's non-magnetic, but I'm reflective like the stars in the sky. I'm soft in my pure form, but you can shapeshift me into anything you want because I'm ductile and malleable.
That's amazing. We love a hot star. Where can people find you if they need you?
I'm the most abundant metallic element in the Earth's crust, so you guys can rely on me no matter where you are. I'm a charge of 3, which is just 1 away from a half-full shell, making me extremely stable.
Like boron, we always love a stable and reliable element. But why are you important in our society? What makes you different from every other element?
Almost 4,000 years ago, the Egyptians and Babylonians would use me to make medicine. My isotope aluminum-26 has even been used for moon and meteorite studies, which means I've seen everything from Mesopotamia to the moon. I'm a key historical figure, so you guys should honor me.
Since you mentioned your isotope, aluminum-26, tell us more. Do you have other isotopes?
I have 9 isotopes with mass numbers ranging from 23 to 30, but only 2 are naturally occurring, aluminum-26 and aluminum-27. Aluminum-27 is a stable isotope, while aluminum-26 is radioactive.
Thank you so much, aluminum. On to the next element. Who are you here with?
Gallium.
Hi, gallium. Externally, you kind of look like boron. How are you different?
I react with acids and alkalis, specifically sodium and potassium. I'm stable in dry conditions, but under moist conditions, I oxidize until a protective layer forms. I have a density of 5.91 grams per centimeter cubed, meaning that I'm less dense than most metals. So you definitely don't have to worry about my intelligence.
That's great. We can all tell you're a bright one. But now you told us some of your chemical properties. Tell us more about your physical properties.
I'm a super soft silvery white metal. You can cut me with a knife like you cut your butter for your morning toast. Moreover, I have a low melting point and I expand when I solidify. However, I remain as a liquid at low temperatures. I'm a great conductor of electricity, and my conductivity increases as I go from a solid to a liquid.
That's amazing. I love butter with my toast. Toast is always reliable, but how do we know you're reliable?
I have 2 stable naturally occurring isotopes, gallium-69 and gallium-71. Gallium-69 has an abundance of 60.11%, while gallium-71 has an abundance of 39.89%. When you put these 2 percentages together, I really make up 100% of our society.
That's great, but if you really represent 100% of our society, where can we find you in the real world?
I'm using something you guys all love, smartphones. Not only that, but I'm also used to make calculators. Without me, you guys would all fail Mr. Ting's tests. Additionally, I'm used to make LED lights, so you know I could always light up your world.
That's great. I love my smartphone. Is there anything else you want to share before we let you go?
Yes, I can actually convert electricity directly to light. Not only that, but I have the highest temperature range as a liquid out of all the elements, so you can literally melt me in the palm of your hands.
Alright, bye guys.
A few moments later.
Who are you here with?
Indium.
Hi, Indium. Tell the audience about yourself.
I'm a super soft silver white metal, and I'm solid at room temperature. I have a melting point of 156.6 degrees Celsius and a boiling point at 2072 degrees Celsius. I also burn with a violet flame, which is really cool.
Wow, I love violet. I wish I could see that everywhere.
Well, you can find me in zinc, iron, lead, and copper ores, so if you're a miner, you could probably find me pretty often. In general, though, I'm super rare with an abundance of zero point 0.1 parts per million in the Earth's crust.
Wow. I already think you're amazing, but as always, how do we know you're reliable?
Although I dissolve in acids, I have 39 naturally occurring isotopes, my most common ones being indium-113 and indium-115, which are my two natural stable isotopes.
That really makes me feel secure, but how exactly are you relevant to our lives?
I'm actually more relevant than you think.
Really?
I'm used in making tin oxide, which is an important part in creating flat screen TVs and touchscreens, which I know you guys all love. Additionally, I play an important role as the world steps towards renewable energy. I'm involved in the production of solar panels, which are increasingly being used as people want to create a cleaner environment.
Wow, that's so considerate. I can really see that this group cares about the well-being of the world. Who are you here with?
My name's Thallium.
Hi, Thallium. You're the last to be interviewed. Please tell the audience about yourself.
I'm made for low temperature thermometers and optical lenses. Historically, I have been used as a rodenticide and insecticide, meaning that I'm unfortunately poisonous and of limited commercial value. However, I'm also used for the imitation of precious jewels, so you can always count on me in case you can't afford the real ones.
That's comforting to know. We all hate rats and insects, and we all want to seem rich. Now, tell the audience about your physical and chemical properties.
I'm soft and have a low melting point. I oxidize upon prolonged contact with the air, and I'm a reactive metal. Even though I might seem like I'm part of a quadruplicate, I'm different. I'm heavy and whitish-bluish in appearance. I have a boiling point of 1,473 degrees Celsius and a melting point of 304 degrees Celsius.
Great. I can tell Group 13 is like a family. That's really good for our government. Tell us about your abundancy in isotopes.
I have two natural isotopes, thallium-203 and thallium-205. I'm super rare with an abundancy of 0.7 parts per million in the Earth's crust. About 29.5% of that is made of thallium-203, while the other 70.5% is made of thallium-205.
Great. Group 13 is made of rare and abundant elements. Such diversity. Now, before we let you go, is there anything else you would like the audience to know?
Our group is like a family. Even though four of us look the same, we have differing properties.
Really?
If Group 13 wins at the end, you all get slime. Bye, everyone!
Hi, I'm nihonium. I was created in 2003 in Russia, in 2004 in Japan, and officially put on the periodic table in 2016. I'm a pretty mysterious element that was recently discovered, and I'm extremely radioactive.
What do you mean?
My most stable isotope is nihonium-296, with a short half-life of about 10 or 20 seconds, making it very hard to study. I have no known uses, and my appearance isn't completely known either. However, I'm believed to be silver/grayish.
Oh, where can we find you?
You can't. I'm a synthetic element, so I have to be created in a particle accelerator.
Cool. What are some of your properties?
I have a boiling point of 1,100 degrees Celsius and a predicted melting point of 430 degrees Celsius. I also have a predicted density of 18 grams per centimeter cubed.
Wow, that's a lot of predictions. Anyways, that's all the time we have for today. Bye!